Okay, ligand substitution of Ferroin. So for this experiment, we need a water bath, and I have it set. There's the water bath. It's set at that temperature. Okay, so it should maintain a constant temperature of 30.0 degrees C. All right, and in the water bath, I have a test tube rack. Okay, and I also have a test tube rack outside, and this is going to have our mixtures in it. So we have 6 test tubes here. Okay, the first test tube has Ferroin in it. That's the red colored stuff. And then I have a tube of A with a mixture A and mixture B, and then a second set of A and B for the other temperature, so I won't use those right away. And then I have a blank. And the blank is used to calibrate our spectrophotometer, okay, which we already should know how to do, and I've already done. And as you saw, I've already pipette and made the mixtures necessary for that. I'm also going to need a couple of stopwatches, one labeled for A, one for B, and a box of Kim wipes and a towel. And then I had to use the Ferroin. This is the concentration of the Ferroin, 5.0 times 10 to the minus 4 molar. And the reaction I'm doing is with the 0.020 molar copper nitrate. Okay, so that's the one of the 3 that are a possibility to be assigned. So to make those mixtures, I had to use graduated pipettes, and so I used one for copper, one for water. So these are 10 mil, these two are 10 mil pipettes measured in 1/10. And as you can see, it says blow out. So if I had to go to the bottom, I'd have to blow out the tip to get to 10 milliliters, but we didn't have anything like that, so I just went line to line to measure out the copper and the water. When we get started with the reaction, I'm going to use and add a small amount of Ferroin, and for that I'm going to use this graduated pipette. As you can see, it says 1 in 1/100th. So in this pipette, if I deliver the whole thing, it's exactly 1 milliliter. So if you can see on here, I don't know if you can see it on camera or not. I'm trying to get it on there. There it is. You can see it's a 0.1 milliliter, that first large line. So each of the smaller lines is 0.01 milliliters. So it's measured off in hundredths of a milliliter. So 0.1, 0.2, 0.3, right, all the way to a full 1 milliliter. So I'm going to use this type of graduated pipette to measure the Ferroin when we get the reaction started. But in order to do the reaction, I need the materials to be at thermoequilibrium with the 30-degree bath. So I have to put the test tubes in the water bath and let them come to temperature. And so that takes 5 to 10 minutes. So we'll get started on that, and then we'll come back in. Okay, so I've got the samples. They've been in the hot water bath for a good long time. So they're at the right temperature. It's still 30 degrees. I'm not showing you that. I'm going to explain how this is going to work. Okay, because this is the data, collecting the data is not a trivial process. Okay, so what's going to happen is I'm going to, over here, I've got my stuff in the bath. I'm going to use my pipette to take some of the Ferroin and put it into one of the test tubes, mixture A. I will quickly take it out. I will use a little piece of parafilm to put on the top, invert it a couple of times. When I mix it, my assistant will start the A stopwatch. So the A stopwatch, right, you'll hit this button here. Whoops, sorry, I'm trying to get it so it doesn't glare. And you get started, okay? Then I'm going to wipe off the outside of the test tube, wipe it off with the Kim wipe, stick it into the Spec 20. When I record the absorbance, you're going to hit the split timer over here on with my thumb, okay? And so you record the time, and then you'll record what the absorbance value will be. Okay. Now, while I hit that split timer, right, the time keeps continuing to accrue while it's going on. So what I'm going to do is take the the test tube out of the Spec 20, put it back in the water bath so it doesn't change temperature that much. So I'm going to do that as fast as possible. Okay? And so we just need to record the time, and so after we've done the recording, I hit the split again, and you can see that it's now up to 50 seconds because it's been going this whole time while I've been explaining this to you. Okay, so now this is stopwatch A for mixture A. Okay, so this has gone a minute. I won't take another reading for mixture A for until it gets closer to 4 minutes. Well, I'm not just going to wait around while this keeps going. As this is going here, as we're getting closer to 1:30 here, 1 minute 30 seconds, closer to 2 minutes, what I'm going to do then is measure Ferroin into mixture B, do the same process, invert it. When that gets inverted and mixed, I will start stopwatch B. Again, I will wipe off the side, stick it in there, stick it into the Spec 20, and we'll take a reading. When they take the absorbance reading, I hit the split because that's the time I took the reading. Let's say it's 10.51 seconds. I will take it out of there, put it back into the water bath. All right, and again, I record the value, the time, and the absorbance for B, and then I will hit the split again. Again, it's been going on in the background. It was a little faster this time. Okay, and so I won't do B until B gets to 4 minutes. Well, but while I've been doing this with B, stopwatch A keeps going. So now we're up at 2.5 minutes. So when this one is going to get to, A is going to get to 4 minutes, I'm going to have to read A. Again, pull it out of the water bath, wipe the sides down to dry it off, wipe it with the Kim wipe, stick it in there. And again, at that point, when this gets to 4 minutes, I'll put it in. It might not be exactly 4 minutes, but I can hit the split button, and I would record whatever time it is that goes. Okay, so let's say that was 4 minutes. Then I would let it go again. Then this one comes up to 4 minutes, and I'd have to read B. Then I'd go back and read A when it gets to 8 minutes, roughly. Then I read B when it gets to 8 minutes, and vice versa. I read them both, right? So I'm collecting both sets of data at the same time. What you want to do, though, is you don't want to have the test tube out of the water bath for very long, because then it's no longer at the 30-degree temperature. So this really is a two-person process, because the one person is putting things in and out of the water bath, the other one is controlling the two stopwatches and recording the data. Okay? But how long do we keep taking data? Every 4 minutes, but for how long? Well, what we're going to do is whatever the first absorbance reading is, we're going to keep collecting data until the absorbance is 1/2 of that original value. So if the value was 0.846, you would keep recording every 4 minutes until it gets down to 0.423. So you can see here now we're at 4 minutes here with the A, so I'd have to read A again, let's say at 4 minutes, 0.89 seconds. Okay, then I would put that back into the water bath, and we just keep going. Right, and so now I don't have anything to do until this one, until B gets to 4 minutes. Okay, so that's how we're going to do this. Now I'm not going to sit here and record this because it's going to take a while for it to go from, let's say, 0.846 to 0.423. It may take up to an hour. Right, we want 10 to 15 to 20 data points, so this is going to take a while. So you're not going to have to watch the whole video for this, but I wanted to explain how we're going to do this. We have two stopwatches, and we're taking readings every 4 minutes on each one, but they're offset. So you're actually taking a reading roughly every 2 minutes as we're going along here, either A or B. All right, so hopefully that's relatively straightforward. And this is at the low temperature. Okay, and so that's why I'm doing this one first. Once we're done with the low temperature data, we're going to turn the temperature up. Okay, and then we will be doing the same procedure that we're doing here, except instead of taking a reading every 4 minutes on A and every 4 minutes on B, we're going to take a reading every 2 minutes on A and every 2 minutes on B, which means I'll be taking a reading every minute, one or the other. Now that one we have to go to 2 half-lives, meaning we have to get it to 1/4 of its original absorbance, but it doesn't take as long because we're at a higher temperature. And so that one doesn't take as long, but again, we need to collect about 15 data points or so, okay? And so since we're only going every 2 minutes, that'll only take about a half hour. So that's kind of what we're going to do, and you're going to get a set of data from your instructor. So you don't have to watch this for the whole time to collect all the data. But you will have to do the workup, which is the whole second week.